Physics Form 5 Lower, Unit 1, Force and Motion, Chapter 4 Momentum. Momentum. Momentum is a quantity that possessed by the masses in motion. It measures how difficult it is to stop an object that is moving. Momentum can be found by the equation momentum equals mass multiplied by the velocity. In simple form, P equals mv. Units of momentum is kilograms meters per second. Momentum is a vector quantity because velocity is a vector quantity. It has a direction and a magnitude. So let's solve a problem in finding momentum. If a car in 1000 kilograms travel at a velocity of 5 meters per second, what is the momentum of the car? So here we can use the equation momentum equals mass multiplied by the velocity. The mass of the car is 1000 kilograms and the velocity of the car is 5 meters per second. Therefore, the momentum P of the car is 5000 kilograms per second. The relationship between momentum and the collisions of objects. The total momentum in objects after a collision remains the same. Therefore, we can use the equation momentum before collision is equals to momentum after collisions. In this figure, we can get m1 multiplied by v1 is the first collision of the mass m1. m2 multiplied by v2 is the initial collision of the m2. That is equal to the momentum after the collision. When the m1 and m2 objects coming toward the opposite directions, these two objects collide. And then afterwards, the momentum after the collision remains the same. Therefore, we can get the momentum after the collision as m1 multiplied by v3 plus m2 multiplied by v4. Since the momentum is a vector quantity, we have to consider the directions of the momentum. If the direction is opposite, we have to get the momentum as negative. Let's move on to a problem that is related to momentum and collision. A car that is 800 kilograms in mass is moving at a velocity of 5 meters per second to the direction east. And a tuk 400 kilograms in mass is moving to the west at a velocity of 5 meters per second, and they collide with each other. If the car moved to the west direction, which is the opposite direction that was traveled with a speed of 1 meters per second, what is the velocity of the tuk after the collision? In this question, we have to consider the velocity, the directions of the velocities of the tuk and the car, because the car is moving towards the east direction while the tuk is moving towards the west direction. Now we will apply the data into the equation. The sum of the initial momentums of the vehicles is equals to the final momentum of the vehicles after the collision. Therefore, the mass of the car is 800 kilograms. While we take all the velocities towards the east direction, the velocity of the car, which is 5 meters per second, is positive. And then we will take the velocity of the tuk, which is also 5 meters per second, towards the first direction as negative because the velocity of the torque is going towards other direction, so we have to use negative or minus in order to make it into the equal or the same direction. And then we apply the data of the final momentum of the vehicles like that. And then we simplify the answer as 3 meters per second as the velocity towards the east direction, which is the velocity of the torque after the collision. The conservation of momentum principle is applied to explosions as well. An explosion releases energy, and because of that energy, it causes the things that is in the object that has exploded to fly apart. Maybe it can be broken into 2 or 3 or many pieces. Therefore, in an explosion, the initial momentum of the exploded object is equals to the final momentum of the broken pieces of the object. Now we will look at a problem related to momentum and explosion. An airplane with a mass of 5,000 kilograms that had a speed of 10 kilometers per hour exploded and broken into two pieces A and B. The mass of the piece A is 2,000 kilograms and the mass of the piece B is 3,000 kilograms. And they fell towards the same direction that the airplane was moving. If the piece A fell with a speed of 5 kilometers per hour, what was the speed of piece B? In this problem, we can take the momentum of the airplane before explosion equals to the momentum of the piece A after explosion plus the momentum of the part B after the explosion. When we apply the data to the equation, we don't need to consider about the direction of the pieces of A and B because the pieces have fallen towards the same direction that the airplane was moving. When we apply the data to the equation, we get the velocity of the piece B as 13.3 kilometers per hour towards the same direction that the airplane was moving. Newton's laws in motion. The first law: things don't speed up, slow down, or change direction unless you push or pull them. Second law: the bigger the force acting on an object, the faster the object will speed up. Third law: when you push something, it pushes you back just as hard, but in the opposite direction. So you have learned the first and the second laws of Newton's in earlier chapters. Now we will look at the third law. When you push something, it pushes you back as hard as, but in the opposite direction. When the M1 ball hits the M2 ball, which is not moving, what happens after the collision is M1 ball moves to the opposite direction and M2 ball also starts moving. This is because the conservation of momentum. Now we will look at the relationship between momentum, acceleration and force. The momentum of a moving object can be taken from the multiplication of the mass by its velocity. If we need to speed up this object, we have to apply a force that causes an acceleration. So the initial momentum of the object can be taken as mu, and the final momentum of the object can be taken as mv. Therefore, the increase in momentum or the change in momentum can be taken by subtracting the final momentum by the initial momentum, which is mv minus mu. Now we can find the rate of increase in momentum or the rate of change in momentum by dividing the change in momentum by time, which is mv minus mu over t. From this, Newton has identified a proportional relationship between the rate of increase of momentum and the force applied. So we can take the equation as F equals mv minus mu over t. This equation can be rearranged as F equals m multiplied by v minus u over t. So you know v minus u over t is equal to the acceleration of an object. Therefore, we can rearrange this equation as F equals ma, which means the force applied is equal to the mass of the object multiplied by the acceleration. Now let's see how the relationship between the momentum, acceleration and the force is applied in problems. If a man pulls a trolley mass of 20 kilograms with a force of 20 newtons from rest in 10 seconds, find the change in momentum. In order to solve this problem, we can apply the equation the force equals to the change in momentum over t, which is the time taken. From this we can rearrange this equation as mv minus mu, which is the change in momentum, equals to F multiplied by t. So we can get the answer as 200 Newton seconds or kilograms meters per second. The second question, find the velocity of the trolley after 10 seconds. This trolley was moved from rest. Therefore, the initial momentum is 0. Then if we apply the change in momentum to this problem, we get the final velocity of this trolley. Therefore, when we apply the data to the equation of the change of momentum, we get the velocity, the final velocity of the trolley as 10 meters per second. The third question, find the acceleration of the trolley. In order to find the acceleration of the trolley, we can easily apply this data into the equation of F equals ma. Therefore, the acceleration can be taken as 1 meters per second square after applying the data into the equation. So I hope that you have gained some knowledge about momentum. Hope you enjoy the video. Thank you. Bye.